Hello everyone. Here we will discuss about the construction of optimal binary search tree using dynamic programming. The dynamic programming in the sense we will use the table structure. By using the table structure we will identify the optimal value for given problem statement. So for constructing the optimal binary search tree we are giving in the problem statement with the number of keys. So here keys are B, C, D. So four number of keys are given with two kinds of probabilities. So here successful probability or frequency is given for A, B, C, D. Four keys are having four kind of probabilities, and there is unsuccessful frequencies also there. So here for unsuccessful we are getting five keys, right? Five probabilities. So 2, 3, 1, 1, 1. So here what is the unsuccessful probability and successful probability? So when we are trying to identify the binary tree, for example, for four keys I am constructing the tree like this. For example, A, here I am having B, then here I am having the C, then here I am having D. So for this I'm substituting the values like for A I am substituting the 15, for B I am substituting 12, then for C I am substituting 20, then for D I am substituting 30. So here you see, when I am trying to identify the value, right? My searching value is now 12. So if it is the 12, then first I will check the root, right? I will compare with the root. So 12 is less than the 15, then my searching process will get into the left subtree, right, by ignoring the right subtree. So now it is checking the 12 is not available or available with this node. So 12 is comparing with now my searching value 12. Okay, so this is node value, this is searching value. Okay, so now both are equal, then immediately my algorithm will return the value 12 is found in the given binary tree, right? So this is called successful probability. For successful probability we are getting the values here for each and every key, right? For finding the for finding the A we are having the frequency value 3. That means the A is frequently searching by the people three times, like that is the meaning here. Then B is searching by the people in the past, so three times. C is searched by the people one time. So that is the meaning of this one. So here you see for D and C we are having the values of searching for searching frequencies is one time. So like this, suppose I am giving the value 10. Okay, so 10 is available or not in the given binary search tree, right? So here what will be happen? So 10 will be compared with the root value, right? Initially, then 10 is less than the 15, so immediately the right subtree will be ignored, then get into the next child, left child, right? Then again here it will check 10 with the given node 12. So 10 is less than the 12, then it will check, it will get into the left subtree. In the left subtree we are having the null nodes. Okay, we are having null values. So here it will check the 10 with the null. Okay, so then it will say there is no node in the left subtree. Then what will be happen? 10 should be given as a not found in the given binary search tree. So here this is called unsuccessful frequency. Unsuccessful frequency. Okay, so the value which is not available in our given keys, or which is not available in the given binary search tree, then that should be said the not found. Okay, if it is a value or not available, we have to return the value is not found. That is called unsuccessful frequency. So here based upon this, you see, when we are having the values like this, okay, here 20, right? For example, here I'm having the 10, here I'm having the 30, then here I'm having the 40, right? So if I have the values like this for 20, right, I'm giving the values like this 20, 30, here 40, right? So if I have like this, then I can say, right, so for searching the 20, this is the value, so key value is here 3, right? I mean successful key value is 3. Then for 30 successful key value is 1. For 40 successful key value is 1, right? For 10 successful key value is 3. So that means this is B, this one is A, this one is C, this one is D. We substituted the integer numbers instead of alphabets. Suppose to find the less than the 10. So to find the less than the 10 null values, if it is less than the 10, that means 9, okay, minus infinity to 9, then this null node will become as a not found value, null value, okay, not found value. So for this we will give the key here 2, okay, less than the 10, okay, less than the 10, that means minus infinity to 9. So here the frequency value which is given unsuccessful frequency here 2, right? Like that here 10 is we are getting the successful frequency 3. Then for getting 11 to, okay, 11 to 19, because 20 is available here successful, 11 to 19 we will get another null value, okay. So right, as per the binary search tree concept, right subtree should be greater than the root node. So here root is the 10, here 11 to 19 is the right subtree. So here for finding this one we are having the frequency here, this one 3, okay. Then for finding the 20 we are getting the successful frequency 3. Then likewise here 20 to 30, 20 to 21 to 29, okay. So here for that, so here we will get, right, so less than the root value here 21 to 29, so frequency value is here 1, okay, frequency value is here 1. Then 30 is this one, right, successful frequency, right, successful frequency. Then 31 to 39, right, this is unsuccessful frequency. So for that we will give the values 1. Then 40 we got the value 1, so that is given here successful frequency. Then here 41 to infinity, right, so these values are not available in my binary search tree. Then for this unsuccessful frequency is 1. So like this we have to construct the binary tree like this. So here these unsuccessful frequencies are given as a null nodes. So here you see these are all null nodes, right? So here these are all leaf nodes as a null node. So this is the concept behind this. Based upon that, here we have to construct the binary search tree that should be giving optimal value, that means minimum cost, searching cost, okay. So based upon this, here I am going to write the algorithm, right. So for the n number of possible keys, so how many number of keys are here? So the keys are here 4. If our keys are 4, then there is the possible number of binary trees are 14. So instead of constructing 14 number of binary search trees, we are going to apply the dynamic programming method, right? So here we will construct the single binary search tree, but indirectly we will use we will construct all kind of binary search trees with less time. So here the algorithm is given, I is starting from the 0 to n minus 1. So here we are having 4 number of keys. Then we will construct from I equal to 0 to n minus 1. So 3. So 0 to 3, right? So like that when you are constructing, right? So here the values, here we have to calculate the weight, right? Then this is unsuccessful frequency, then this is root, right? We have to find out the nodes position in the binary search tree. Suppose if I have the nodes like this, okay, so here I have to check the binary search tree like this. So the nodes position has to be identified, that is the r of I comma I. Then cost, searching cost is mentioned with C. So here whenever we are having the same index values, okay, w of I comma I, 1 comma 1, 0 comma 0, 3 comma 3, like that when you are constructing that, so we have to give the value is q of I, right? right? So if it is w of 1 comma 1 means then q1, this is called q1, right? So right, like this, here we have to initialize the index. So this is the q1, this is 0, so we have to give the index values 0, 1, 2, 3, 4, like this. Okay, so we have to give the index like this. Okay, so now then if the tree is having single node, then we have to use the q of I plus 1, p of I plus 1. Root will be r of I comma I plus 1 is I plus 1, right? Like that we have to identify the cost. Then here for initializing the values, right, here w of n comma n, 4 comma 4 or 3 comma 3, we are yet making the frequency values. Here root values, here cost value c of 1 comma 1, that means 0, right? So like that we have to initialize the values. Then here we are starting from 2 to n, right? 2 to 5, 4, okay, 2 to 4, right? So we have to start, we have to do that, right, for constructing the optimal trees with the m number of nodes. Then here we are starting from inner for loop. This is actually we are going to construct the number of columns. So this is number of rows, this is number of columns, right? Then we will construct, we will calculate the j value here, right? J is the columns, right? Then weight to be given, w of I comma j is w of I comma j minus 1 plus successful frequency of the respective j value, unsuccessful frequency of respected q value. Then here we will identify the minimum value, right? So in the minimum value, you see, we have to initialize initially in the table infinity for all the cells. Then we will identify the minimum value by using this uh, um, formula c of I comma m minus 1 plus c of m comma j, right? Here we are using the m here, but in our formula we will use k value. Okay, c of I comma k minus 1 plus c of k comma j. So like this I used in my formula. So then if it is minimum less than the infinity, then I have to consider minimum will be this value. Okay, so based upon this, then I have to find out the cost with respect to this formula, right? C of I comma k minus 1 plus c of I comma j, k comma j plus the w of I comma j. So this is the value finally we have to identify. So minimum value, right? Minimum value that should be for k, right? So finally which is giving you the minimum, that will be considered as a root. So based upon this, right, I have formula, make the theoretical formula. You see c of I comma k minus 1 and plus c of k comma j w I j. So this formula, then here based upon this method, I have to identify minimum value for different k values. Okay, so k is the value, right? Here we will have more than 1k, right, sometimes. So in that, which k is giving you minimum value? So based upon that, I have made this formula, right? C of I comma j equal to minimum of I less than, okay, I less than k less than or equal to j. So this is done with respect to this for loop. Okay, then we have to use the formula, right, what we are deriving here. That, right, for calculating the w of I comma j, we used the formula this one, right? Then for finding the minimum value here, which k is giving, that will be acting as a position of the particular value node. Okay, so based upon that, finally the cost of the node, then weight of that node, root of that node, I mean position of that node is written here, right? 0 comma n, 0 comma n, 0 comma n, like that. So based upon that, now I'm going to solving this problem, right? So here we will start with listed values, right? So here we have to build the table. Then in the table we will apply the dynamic programming to calculate the values by dividing the bigger problem into sub problem or smaller problem. Then smaller problem will find the solution. The solution of the smaller problem will be using for solving the bigger problem, right? So based upon that, here you see, first create the table for weight, cost and root, right? So here table index will be 0 to n minus 1, right? So here based upon that, we are going to identify the values. Okay, so the table is constructed, and initially as per the algorithm, w of I comma I will be qi, c of I comma I 0, r of I comma I 0. Then I have to calculate the zero cost for 0 of n minus 1. So here we have to identify here 0 1 2 3 4 index values. So here we have to identify this. So 0 comma n, not n minus 1, right? So this is 0 comma n. So 0 comma 4, n equal to here 4, right? So here also 0 to n, right? So now I have to identify the values here, c of 0 comma 4. Then minimum of, as per this formula, I value is here 0, right? J value is 4. Then c of here I is 0, right? K is here given less than or equal to, here j is here 4, right? Then c of I comma k minus 1. So k is having 4 probabilities: k equal to 1, k equal to 2, k equal to 3, k equal to 4. So for 4 k values, we have to identify c of I comma k minus 1. So initially we will identify for 1, then we have to calculate for 2, then we have to calculate for 3, then we have to calculate for 4. Then w of I comma j here 0 comma 4. For w of 0 comma 4, we can identify this formula, right? Based upon this, here we have to construct the table 0 to n. 0 to n is 0 to 4. Here you see 0 to 4, right? Index values. So here how do we identify the row index values? So row index values here we can identify based upon this formula, right? So here based upon that formula, I am substituting g of 0 comma 4. First I am calculating for the k equal to 1, k equal to 1. So c of here I is 0, j is 4. Now c of I is here 0, right? K minus 1, 1 minus 1 is 0, plus here k. So k equal to 1, j equal to 4, right? Comma, then I am substituting here, k is having 4 probabilities. Okay, k equal to 1, then 2, then 3, 4, right? So I am calculating for k equal to 2 here. I is 0, then k is 2, 2 minus 1 as per this formula 1. Then here k is here 2, j is here 4, comma. Then now I am substituting for k value is 3, then I value is 0, k minus 1 is 3 minus 1 2, then here k value is 3, then j value is 4. Okay, then I am substituting k equal to 4, right? Then I is 0, then k minus 1 is 3, then k value is 4, then j value is 4. Then when I am going to for k equal to 5, but there is no option, only k equal to 1 2 3 4, right? Then plus the, as per this formula, w of 0 comma 4. So based upon this, now I have to identify. You see, we have derived the bigger problem c of 0 comma 4 into smaller problems, right? You see, this is one problem, c of 1 comma 4 another sub problem, c of 0 comma 1 is another some smaller problem. So like this, we are divided this bigger problem into many smaller problems. Now we are going to construct for the smaller problem, right? This step. So c of 1 comma 4, right? C of 0 comma 0, that is 0, already we found in the previous slide. So C of 1 comma 4, here we are going to apply the formula now, same formula. When you are applying this, here you see k is having again multiple options, k equal to 2, right? 1 less than, k less than or equal to 4. So 2, 3, then k equal to 4. So for these three terms, we have to apply the formula here, right? Again, C of I. So I is here 1, j is here 4, right? So for k equal to 1, right? C of I comma k minus 1, right? So here k equal to 2, right? This value. 2 minus 1 is 1, then here k value is 2, then j value is here 4. Then we have to find out for k equal to 3. Then here I is 1, k minus 1, 3 minus 1, then k value is 3, then j value is 4 based upon the formula. Then k equal to 4. So here I is 1, k minus 1 is 3, right? Then k value is 4, then j value is 4, right? So then for all the k values we found the formula. Now this is I comma j. Again you see we divide the problem 1 comma 4 into again small problems. So here for this bigger problem, again we got so many number of smaller problems, right? So again we have to identify the values. So for C of 1 comma 2, right? For C of 1 comma 2, here I am finding the formula, right? 1 less than k less than or equal to 2. So here we are having k equal to 2, so only single value, right? When you are substituting, I is here 1, j is here 2, then k minus 1 is 2 minus 1 is here 1, then k value is 2, then j value is here 2. Then w of 1 comma 2 we have to identify based upon the formula, right? Then here we have to identify next term 1 comma 3, right? So smaller problem next is this one, we are identifying 1 comma 3. So when you are applying the k less than or equal to 3, here we are having k equal to 2, k equal to 3, right? So again this problem is broken into smaller problem based upon the I. This is k minus 1, k, j value. We got these values. Based upon this, I equal to 1, j equal to 3, right? Again this is for k equal to 3. Here I, k minus 1, k equal to 3, j. Then here I comma j. Now again we are going to finding the one more sub problem 2 comma 3, right? So here we are identifying the value for 2 comma 3 for this sub problem, right? So for this k is having, right, only one value 3. So I is here 2, j is here 3. So I is 2, k minus 1, 3 minus 1 is 2, then k value is 3, then j value is 3. Then w of I comma j, right? Then again here we are going to identifying c of 0 comma 1. So for C of 1 comma 4, we are having these many sub problems, okay? 1 comma 1, 2 comma 4, 1 comma 2, 3 comma 4, 1 comma 3, 4 comma 4, right? So here we identified the values for 1 comma 2, then 1 comma 3. Still we have to identify the 3 comma 4, 4 comma 4 already it is 0. So in this 1 comma 2 we found, then 1 comma 3 we found. In the 1 comma 3 we found one more value, that's what 2 comma 3 we found. Now we are going to identify 0 comma 1. So for this 1 comma 2 already we found, that's why we left that. So next term c of 0 comma 1, right? So for this we are going to identify all these terms are for this sub problem. Now we are going to identifying for the next sub problem, this one, right? So when you are substituting the formula as per the explanation of this step, you are getting this term, right? Then you are identifying the next sub problem solution, c of 2 comma 4. Now you are having the k equal to two values, 3 comma 4. So this is for k equal to 3, this is for k equal to 4, right? Then here you are identifying one more sub problem, this one, right? When you're applying this, k is having two values, k equal to 1, then k equal to 2, right? Then one more sub problem for this one, right? Here k is having only one value, that is k equal to 4. So when you're substituting the index values I comma j comma k, then you will get this formula, right? So now again we are having one more sub problem, this one. For this you are going to substitute the formula. Here you are having k equal to 1, k equal to 2, k equal to 3. So based upon that, finally you see we got the sub problem solution, right, for all the sub problems. Then we can substitute the values from bottom to up, then we will get the solution for c of 0 comma 4. This is the procedure for dynamic programming. Then we will construct the optimal binary search tree. So based upon this, you see we can construct the table. Theoretically this 0, how we will get the indices I comma j? So whichever I value and j value we are substituting, for that we should get the 0, right? So here whichever I value we are substituting and j value, we should get 1. Here the whichever I value and j value we are substituting, we should get 2. Like that we have to identify the I and j values. To construct the table we can use these values. You see we will fill from this bottom of the table. So initially here j minus I should give you 4, right? So here you see this is I value, this is j value. So based upon that we can fill the c of 0 comma 4, right? C of 0 comma 4, here we are using this. So when you are subtracting the j value minus I value, you are getting 4. 0 here minus 4 minus 0, you are getting 4, right? So based upon that you can fill this entire column, right? From bottom up, you see you could take this one. So from this c of 0 comma 3, right, this one, then respective root r of 0 comma 3, w of 0 comma 3. So for this value you look at that first term, c of 0 comma 2, this one, r of 0 comma 2, w of 0 comma 2, right? When you're subtracting the values also, you will get this index. Like that the next term c of 0 comma 1, you look at that c of 0 comma 1, w of 0 comma 1, r of 0 comma 1. When you're substituting this 1 minus 0, you are getting 1. Then again when you are going to first term, c of 0 comma 0, c of 0 comma 0, w of 0 comma 0, r of 0 comma 0. When you're substituting the values 0 minus 0, you will get 0. So now we filled the first column, then you are going for second column. So for the second column here we are going for, right, next sub problem. Okay, this is the sub problem c of 1 comma 4, which is available here, right? C of 1 comma 4 we filled here, right? You see when you are substituting the values 4 minus 1, you are getting 3, right? After filling that, now you look at that term, right? This term, right? 1 comma 3. So 1 comma 3 is giving this one. So 3 minus 1, you are getting 2. So the respective w and r value also given. Then next first term 1 comma 2. So 1 comma 2 is given here, right? So respective w and r values. Here 2 minus 1, you are getting 1. So next here you are looking this first value c of 1 comma 1. So like this second column filled. Then to fill the third column, look at here. Here we are getting one more sub problem, c of 2 comma 4, right? Now we have filled this one, right? So 2 comma 4, right? C of 2 comma 4, you look at that we are having here c of 2 comma 4, we got it. So 4 minus 2, you are getting this index value 2, right? Then 4 comma 2, c of 2 comma 3. So c of 2 comma 3 in bottom up manner we are filling, it will satisfy this condition. And c of here 2 comma 2. So c of 2 comma 2 we filled. Second column also filled, I mean third column with the second index, right? Then next one is here another one sub problem, c of 3 comma 4. So c of 3 comma 4, only one value is there, right? That is c of 3 comma 3, right? So C of 3 comma 4 and C of 3 comma 3. Then finally here we are filling this one C of 4 comma 4 with respective weight and root values. So this problem, now we have constructed the table. Okay, then we will apply the dynamic programming, like whatever we have constructed, the bigger problem is divided into sub problems. So we will find the solution for each sub problem in the next video. Thanks for watching.